for what? For this codes, and then so far the training and everything. Oh, did I record it? Yeah, stop it. Okay. I'm
Yes,
just trying
it's
to give
already started.
now Brian and Gabriel the permission to share. And Brian, where is Brian? So you'll be able to share your screens as needed. So thank you so much for working on it, and then working on the record linkage. And then although in the last minute there was change in the data set and everything, thank you, Brian, for taking into that consideration and then still working as well. So thank you. And maybe I'll just ask maybe Gabriel to maybe share what you have, what you were
Sure,
mentioning.
but the user I am to with the computer is Gabriel Long.
Ah,
Is my
Gabriel.
user?
Okay, okay, okay. Sorry, I gave you
Yes,
the different. Okay. So if you have the
yes,
permission now.
yes. I
Okay.
believe you can see my screen,
Mm-hmm.
and this is the code that Brian sent me, and this is the datasets I have. I just was wondering a little bit about more about the process. Was what I was studying this, but I wanted to check with you. And it runs correctly all the screen with all the processing code.
Hmm.
Mhm.
I was wondering also a little bit about the thing you said about blocking with the department,
Yeah.
about how can this be done.
So that is well. Do you want to talk about that first, or do you want? First of all, this is not the big data set, right? This is still a small one. It's only 40 observations, right?
Yes, this is
Okay.
the small one.
Okay. Um, yeah, there's in in the stuff I sent out last time, there's information about how to do the blocking. I'll find it again right now, and I could put it in the chat. Um,
Brian, also, do you want to briefly go through the code so everyone knows about it, what you were trying to do and what's the purpose of it?
sure, yeah, that would be a good thing for me to do. So I
Mm-hmm.
can,
Thank
you want
you.
me to first share it on my screen so I could run through and kind of explain each step?
Ah, sure, sure.
Okay.
Mm,
So if you stop sharing, then I'll start sharing mine.
okay.
Um, okay. Um, so um, this is this is the code that I drafted up to help Danny do its record linkage task. There are a couple of packages that are required here. The main one is this fast link. That is the package to conduct the record linkage. And then read XL, that's for reading the CSV files. Stringer is a package to do certain string manipulations and string comparisons. And tidyverse is just something to clean up data in general. Um, so this first block of code just is reading in the data. I needed to do something a little bit more complicated here when you have multiple sheets in the same Excel file. Um, you have to do something to read it in correctly. But that's just now we have the two data sets loaded in to these two names, and we'll be able to do record linkage on those. In this next chunk, we're just acknowledging that the two data sets are structured a little differently. In the GEIH, you have one field that says nombres, which is both the first name and the second first name, and then apellidos, which again is both last names. So here's just some code that splits up those nombre into two, into primero and segundo, and same with apellidos. into primer y segundo. And then these are just changing the names of files so that they match across two data sets. Also, ingreso, the income, was, I think, originally coded or read in as a character, and we just want to change it to numeric. So that's all that's doing, some basic reformatting. And then here is the actual FastLink code. So here we're telling it the names of the two databases and all the variables that we're going to match on. And these are the string variables. And we're telling it to account for partial matches on the string variables. So this is going to capture the fact that maybe Karen is spelled with a K or a C, for example, and it's gonna have a slightly it's calculating this a Levenshtein string distance, and if it's an exact match, then the string distance is 1. But if you have some type of error in it, then the string distance will be a little bit lower. And we're going to want to capture these partial matches so that we have we're able to capture some of these common misspellings. This is not specific to Spanish. However, it should still work for this context. And in future, somebody could program this to have a language-specific string distance or something. But we're going to go ahead and run this on those two data sets. It should not take too long.
Brian, what is cut A, cut P, and threshold match? How did you define these values?
So there are default values. So cut A and cut P, those are the values to determine what is an exact match and what is a partial match. There are default values in FastLink, but I changed them for my purposes. So cut A is saying that in order for me to label something as an exact match, as of the fullest agreement level, it has to be an exact match. The default value is actually 0.94, so it allows for some errors in claiming a full match. I changed it, although maybe we should rerun this also with just the default values. Then cut P is the threshold for the partial. So again, a string Karen and Karen with a K and a C, that will have a slightly less than 1 total string distance. And that's just that cut P is just the threshold for labeling the partial match. Then threshold, that is the model is going to calculate a probability that something is a match. And the default is 0.85. I went ahead and moved it up, but we could keep it to 0.85 if we wanted to. That's just going to help the modeler choose how stringent they want to be with declaring matches. At the very lowest, it should be at least 0.5, right? 0.5 means if it's above 0.5, it's more likely than not to be a match, but you're going to probably want it to be significantly higher than that because you want to guard against false matches. So again, the default value there is 0.85. In the original paper with this method, he also looks at what 0.75 looks like. I figured that here, because we have such discerning information, we have 4 sets of names and an ID number, though it's very, very discerning. So I figured that a higher threshold than normal might be warranted. Yeah, that is the main part of the code. And so we're going to get the code outputs. So this object was called linkage. And then one of the objects in it is the set of matches. So this is the indices in the first data set that have matches, and then I have the indices for the second data set. They happen to be the same indices. And then that allows me to pull out So here we can see it was Erica Lozano Cordano, for example, and it has accurately matched that to Erica Lozano Cordano, right? So it is doing what we want it to do. Then in this last part, we see, I mentioned in the last meeting that so the goal of this little analysis was to see if there is a bias in reporting the income across the two variables, across the two data sets. So we are linking the data sets and then comparing the incomes on the linked data. And instead of just a t-test, which just calculates a difference in means across two data sets, we're going to use a paired t-test. So that's where we have paired equals true. And that's going to take into account that Erica's income, we want to compare that to Erica's income in the other data set. Right now, when we run this paired t-test, it's not exactly information that's that helpful at the moment. We see a p-value that's greater than 0.5, but more importantly, we see this incredibly wide confidence interval. And the reason why that is because here I just coded up the income in one data set, the income in the other data set, and then this last thing is an indicator of whether or not the ID and the type of ID were the same across the two data sets. So that's like that's closest to what you guys are already doing. And I would imagine you might want to filter that out anyway and have only the records that have the match on the ID for example. Um, when we have both of those and the record linkage says that they're a match, we're inclined to believe it truly is a match. And there's a couple weird things happening in here. So for example, like some of these are just like extremely large. And it makes me think that maybe there is some sort of um, difference in currency or difference in sometimes it's a month of information or a year of information or something like that. There might be something broader happening. So at least at this moment, results somewhat inconclusive, but that's what I will, I guess, talk with Gabriel about going forward. Or we'll talk about the linkage stuff, and then also we'll talk about this later part. So yes, that is, I'm going to stop sharing, and that is the run through of the code.
Oh, thank you, Brian. Maybe anyone has any question before we actually start the code in Gabriela's machine? If not, maybe Gabriel, maybe you want to take over?
Sure, sure, I have just some questions about it.
Okay.
I don't know if you can see very soon this. I didn't understand well about this table. This means that these people didn't. This is the income in one in the registers, I believe, and I know in the survey, and this is the link in the income in the administrative records, right? And the column three, what did this mean?
Yeah, I should have labeled that better. Sorry, I meant to. It's just it means that it's an indicator saying that the reported ID number and the reported ID type was the same in the two data sets.
Okay.
So that's just like it's kind of um, a informal sanity check on the record linkage that was done.
Ah,
Yeah.
okay. So So these people actually they only match it in the with the names, but they didn't match it in a deterministic way with the number and the type of.
Exactly. That one. I
Okay.
mean, we could look at it. You can dig back in. That means it differed on either the the ID number itself or the type. I figured that just the
Okay.
type
Well.
might be just like a typo, but it different on the ID number. That might be like, okay, that we might toss that out. Yeah.
Okay. Thank you. Yeah, this was the main question I had. I also this is data I had. Also, I think this is quite interesting. This way to call the sheets, and this is the data we have. This takes a little bit. This actually has about 8 million, 8 million people more or less, which correspond about the information of IDs, number, all the variables I send you.
Hmm.
The age is actually corrected in this data set, and which has about 8 million people, and the next data set that which is about the survey about January 2021 has about 60,000 records. So the main question I might have here is how long do you think it might take to make these two links
Yeah.
between
So with with one being, you said like 8 million. That it's quite possible that Fastlink might you might just get an error. I'm not sure if you just plug those in. When you have time, just check it. But you might get an
Okay.
error just trying to do that. But that's when you could use blocking instead, like I mentioned. So I can. Oh yeah, that's big. I can show you that in this tutorial. I could either share my screen again, or I could just I can send it to you, and then I'll direct it to where it is. Um, so in the I'm gonna put it in the chat here. Conversation.
So the main idea of the blocking thing is that I want the department in one way, the location in the register and the location in the survey. If they are the same, the code will try to link it. If they are in different districts, for example, it will not it the code will not try to link them.
Exactly. It'll instead of
Okay.
doing one big record linkage task, it'll do a bunch of smaller tasks within each department.
Okay. And the other thing I was wondering is the link that the code that you have here about the linkage, it only links with number of type, or this link, oh sorry, this code will link with the only with the names, or this link also do it with the type of ID and number of ID.
Yeah, so in the third line there, bar names, and the first two are numero and tipo. That's
Yes.
the ID number and the type of ID.
Yes, so the link it's also with the number and type.
Yeah.
Okay.
Oh,
Okay,
and
I understand.
when you run this with when you do the blocking, then if you see the third in the var names, the last entry there is departamento final. You should remove that when you are if you've already blocked on it, then you should remove it from the second step. Uh,
Okay,
yeah,
from Barnum's, right?
from var names. Yeah.
Okay, thank you. And I believe this is the last question I may have is about the ages and the sex that that it has had a problem. It's about how do I put these variables in this code. Uh, so I understood with your class that it depended on these variables. It also like the linkage see these variables to know if this is okay, the linkage, if the names, if the ages are right, and if the sex is right, it's like consistent.
Um,
Uh,
the sex, that's me with my like PhD hat on. That like technically it's, yeah, there's a minor issue with using the sex. I would just not use it. I don't think it's that strong of a linking variable anyway. If you put it in, it probably won't
okay.
matter. The age, you should definitely put that in if you have it and if you're able to calculate it accurately. Because it was, but I remember one data set has age, the other one has a date of birth. So you'd have to know kind of precisely when that age was taken. And then there are some packages that can kind of automatically convert a birthday into an age. Um, it- and yeah, but if you have that, then you should definitely use that.
Yes, yes, I actually have it here. Okay. So where did I put the name? Sorry, the variable about age.
Put it in the var names.
Ah, like an extra. Okay, so
Yeah,
this is
just
the.
like add it in there and make sure that the name of the variable is the same across the two data sets.
Ah, okay, sure. Where is the age? I put it here in the survey, and in the yes, I already corrected that. So I will try this, and also no, and also and it's kind of really interesting about the t-test to compare these incomes,
Mhm.
since that the main exercise we want to do with the poverty team to try to take some valuables, some values about income from the register to the survey. And thank you a lot for this code. And maybe I don't know if you know about and I was also in a course today about linking data with administrative records and surveys. And a question emerged, and I wanted to what I was interested in your opinion about who do I believe. If you have experience with this, who do I believe in the sub with the information about the survey and the administrative records?
Yeah, that's an issue that comes up a lot is okay, you've linked these data sets and there's errors in them. So then like what's the true value, right? Um, that is basically most often going to come down to your own knowledge about the data sets. At least
Okay.
from what I've seen in this, I wouldn't know a way to determine that from the data itself. Yeah.
Okay. It's more. It depends in each case.
Hmm.
Okay. Well, I believe that it's my homework to do these linkages
Okay.
with this blocking. I believe I don't know if this is well. It takes a lot of. I believe or I understood that it takes some time, quite time to do these linkages. Um,
Gabriel, have you tried to run it?
Today
Uh-huh.
actually in this morning, but I was also processing another stuff in this computer, so I believe that it wasn't well done the exercise to know precisely if it works or not.
Hmm.
So my main idea was to today at night make the computer take the computer to make the process and see
Hmm.
how does it takes
Okay.
see what
Um,
happens.
one more thing that I'll say, if you let me share my screen again for a
Sure.
moment.
Sure. Stop.
And so, like I said, in order So this is the link I just put in the chat, and it's just the GitHub fast link tutorial. And this shows how to do the blocking. It's pretty straightforward. Oh, there's so much stuff here. So pre-processing matching via blocking. You guys should read this part, and basically it's just this line of code: block data, and it's going to be the two data sets, and this is going to be what you're going to block on. So this would be departamento final, and what that's going to do is give like yeah, it's going to give a list of indices that then allow you to put it into this tells you what subset of the first data set belongs to a certain block. Basically, in order to do this, you're probably going to want to use like an L apply function somehow. You're going to get this, you're going to do this, and then you're going to get this like list of blocks, and then you don't want to have to hand code this for like all 60 departments, right? But there's a way to do it just kind of using all the blocks. If you need help with that, I could write up something very, very quickly that would kind of outline it. It'd be hard for me without having that whole data set myself, but it shouldn't be too hard.
Okay. So it's, I mean, the goal is to do a blog with Lapply to do it in all, or with a one way of a looper to make it in all the departments, right?
Yeah, yeah. So you're going to do the blocking
Okay.
first, and then once you get those blocks, then you use the lapply statement. Yeah.
Okay. So, but also the blocking variable has to be consistent in both when the register and the survey.
Yeah.
So it works.
Yeah.
Okay. I I have to see this happen, but thank you in advance, and I'll tell you how it goes with this blocking
Hmm.
way to do it with the department. Um, yes, so I'll try. I'll do this linkage. I'll tell you how it goes.
Sounds good.
Right.
Yeah, Gabriel, maybe it's best maybe try to just run the code without blocking first if you are unsure of if the blocking variable is same in both data set. Just run it and see if Fastlink actually throws the error or not. If it doesn't throw, it's best. No, you don't even have to do blocking. Otherwise, you can try the blocking
Okay.
approach.
Yeah.
And then
I was just gonna say it's 8 million to 60,000. Even if it's not an error, it would take a while.
Okay.
it would take a while.
Okay. It's quite unlikely that it works. Uh,
Brian, you mentioned you had linked a million to record set, right? Data set. How long did it take?
Oh, did I say that? I don't remember. So
Okay.
maybe you're right. It'll do it. I haven't
yes.
tried it.
Uh, I'll try both ways to.
Mm-hmm, mm-hmm. Also, if you want to add more variable, I think you can just add it in the variable parameter, right, Brian?
Exactly. You just add in the var names part, and then if it is a string variable, then you want to also add it to the next two chunks also, to the string match. And if you want that to be partial, if you want that partial level, then you have to also edit there. Yeah.
But I just got confused. So
Yeah.
I add
You can share the
some
screen then.
variables.
Oh yeah, share the screen again.
So here in this part of this chunk in varnish, I also add some variables and what
Hmm.
it does. And if it's numeric, I only add it here in var names.
Yeah.
And if it is a string, I add in this both.
Exactly.
Both? Okay. So this will matches all the variables I put here, right?
So yeah, so string dist match, all of those need to also be in var names, but var names can have additional variables.
And all of these linkages are with these fuzzy matches, or the matches made by type of an ID are with in a deterministic way,
Yeah,
or
so
all the
type and number, those are going to be like binary choice exact match. It's either exactly the same or it's
Mhm.
not. And the things that we put into string dist match, those are going to be fuzzy. Those are going to allow,
Okay.
yeah, those are going to basically categorize all the exact matches at one level, everything that's almost an exact match as another level, and then things that are far enough away at another level. Yeah.
Okay. I what I understand, if I change this criteria to 1.9 or less, what I'm doing is to smooth or make, so it doesn't have to be so hard, the matches.
Exactly. It's like smoothing
Okay.
in a sense. So if you were to right now, the cut point A means that you're only gonna classify something as a full agreement if it's an exact match. But you could lower that to like 0.94 or something, so that it
Okay.
it captures more. So yeah, the default settings. Let me just um, see real fast what they are. Um,
Um, so which would be a good number or good criteria, like standardized way, or
yeah,
good
so I
practice
mean,
in
if you want,
quality
actually go
match?
ahead and the default setting is the cut.a is 0.92 and the cut.p is 0.88. Um, I
Okay.
personally do it just a little bit differently on my own, but default settings are a good way to start, probably.
Okay. Yes. Like,
Yeah.
William. And sorry, I didn't understand the difference between cat point A and cat point B. Cat point B.
What? Let me give me a second. I'll see if I can show an example. Um,
And I stopped sharing the.
okay. Okay, just give me a moment.
As I understand, cut point A is what is the percentage value that you want that defines it is an exact match, you know. So in your case, if you put 0.92, that means if it is 92% match, it will assume it's 100% match. Right, Brian?
Um,
Or not?
no, so the cut A and cut B, those are for here. I'll share my screen and I'll maybe this will help. Okay. Um, so the threshold match, just to clarify, that is um, the probability that something is declared a match. Here, I'm gonna lower it for a second, and I'm gonna rerun this. And some parts of this are the package isn't as clearly uh, named as I would like, but I'll show you. Okay, so um, and posterior. Hold on. I think it's yeah, I think it's that. Yeah, okay. So this thing posterior, that's that's gonna give the that's gonna okay, sorry. Linkage, $ matches. So this is the set of indices for the matches in the first data set. This is the set of it for the second, right? Then posterior, this is the probability that those things are a match. And all of these are very, very high because, again, you have very, very discerning fields. You have all those names and all the IDs. So this thing is it's pretty confident. But you could imagine if certain things had more errors in them, or if information was um, less discerning. For example, if one of the fields is like someone's hair color, that's going to be prone to error. And like a lot of people have brown hair, whatever. Those things will give you less confident matches. But all these, this is saying that this first record, the model is like 99% sure. All of these, and this is basically 1%, like entirely sure. So this model is very, very sure and everything. So this threshold right now it's only giving stuff above 0.75, but if I change it to 0.95, that's why I didn't change at all, because they're also confident. Now about the cut A and cut P, basically what happens under the hood is that it's creating these comparison vectors for each pair of records. So a 2 is what it is how we represent a full agreement. A 1 is a partial agreement. So here we're seeing that these first data points have a complete agreement on numero. But this right here is that the number was different. So that again is one that you guys might want to just toss out. I'm not sure, depending on how you do this. You might want to just toss that out. But here, this gamma 5 is the fifth thing. 1, 2, 3, 4, 5. Primer nombre. It's a partial match. So we're gonna look at how that looks. So primer nombre for in the one data set was Erica, and the primer nombre here was Erica with a K. Other one was a C, right? So that's a partial match, and the way it's determining that is that it's using like a is this string distance, basically a function like this that is capturing. Why is that? That should not be a 1. Oh, because it's okay. It's doing it's string distance is not a good one because it's using some function that's normalized from 0 to 1. Here, it's actually this. Divided by 5, because that's the length of the string. So it's using something like some function like that that's characterizing how different things are. And that's just setting the thresholds that function uses. So yeah, sorry if that got a little rambly, but those thresholds, if I were to change these thresholds to what we just recommended, we can see if perhaps it changes the coding of Erica. Let's give it So we had that calculated as a partial match. But it might be that it's a small enough error that it still is going to put it as a full match. Let's see. I don't know what that was, but okay, so it actually captured a couple of that. Doing that classification added more partial matches. So let's look at what. So that's saying that the entire first name also had some differences. Maybe I messed up them, but let's see. Oh, okay, it was Erika Lozano Cordano, and here it is. Oh, that's different, right? Coronado and Coronado. Okay, I'm working on this too on the fly, so I might have messed up something there, but that's it's changing how it gets labeled as the one or um the one or the one or the two. There might even be that it's something weird with like a space. In any case, I'm sure that doesn't change the output of the algorithm because we're still going to have, yeah, we still have the same 19 matches and that same basically the same results.
Yes.
Yeah, that's what's happening.
Okay, I understand. Yes, it is smooth. And also, when I change the data, I change two little things about the names, like a letter, or as you see with Karen, I believe. Okay, and yes, I understand the part with could A and could B, and
Mhm.
I can see what you explained in your presentation, and to compare with the data, it's quite better to understand the fuzzy matches. It's
Yeah,
point 92 or 92.
point
About the
92.
cat A. Okay.
Yeah,
Point 92.
it's always going to
Okay.
be numbers between 0 and 1. Yeah,
Yes.
yeah.
Okay. Um. Yeah, Brian. Thank you a lot for the call and the. Yes, I believe I understand how to make this exercise with the all the data we have. Uh, so I will do it to see in both ways that Samuel suggested to see what happens with the blocking and without the blocking. I believe I have no more questions. I'll show the code and the notations you put make this thing quite clear.
Great, I'm glad.
Mhm.
Yes, yes, it's quite good, Brian. Thank you. Advance. Um, yes, I will. I'll try also the exercise to see what happens with these linkage bias. I will do
Mhm.
the test. Is quite better to see what
Yeah,
happens.
I'd also be curious, like, if you're at liberty to disclose, if you want to tell me, um, basically how the results are different from from when you do it the way you were doing before, right? So I know before you basically just use the ID number, and then there's some issues with and there are some issues with like then the type is maybe wrong, but you don't know if you should,
Yes.
but you should be able to dig through this code and kind of identify um, identify cases where FastLink says, okay, the number is the ID number is correct, the ID number matches, the ID type doesn't match, and it should be able to find those, right? And still,
Sure.
and I'd be curious to know, yeah, if you're finding more matches or not, if you're using this. So
Of course, once I have some results, I will send them to you.
great,
All the results I have, and this how this exercise goes with this match.
great,
Of course, I'll share it with you.
Well, great. I think this is really good outcome so far. I think with this, I hope Danny would be able to further use the record linkage and then come up with the new statistics. And then I think as I'm speaking, I think the data for now project in Colombia actually is gonna finish very soon, but it doesn't mean that our collaboration ends now. I think we will be still working together in many other capacity, and then definitely some additional trainings would be there, I believe. I hope so. And then, yeah, thank you so much, Brian and Gabriel and the whole team and Dane for today's session. I think it went, I think, really well.
great.
And
Thank you so much, everybody.
stop the
Yes, and
recording.
thank you a lot, Samrat and Brian. It's quite useful this linkage to the exercise we are actually doing. So we presented quite enough some results today in a in a meeting, but without these fuzzy matches, but about with the deterministic matches, and we told them about the exercise we might have soon with these fuzzy matches. So it's quite useful all these exercises and the code and the understanding of this. Thank you a lot, Samrat and Brian, for this.
Well, thank you. And then if you have any problem, maybe informally Brian can help, no? Especially at the moment, it's almost complete.
Mm-hmm.
Maybe if there is one or two small issue within the code, you can request Brian for informally in the email, no? Like if the for loop doesn't work or something like the one Brian mentioned
Yeah,
for
I'd be happy to.
yeah, small issues. I think it should be very easy. And then hopefully with the second phase also coming, maybe we could still continue as well together.
Sounds good to me.
Okay, thank you. Sounds good to me too. Thank you all.
Thank you. I was just